This video is designed to help you with simplifying rational expressions and solving equations containing rational expressions. So a rational expression simply means that you have a fraction with variable components to it. So what we have here is a binomial over a binomial, and our goal is, just like with regular fractions, is to simplify this as much as possible. So we use our skills of factoring to actually turn this into factored form, which means that we recognize that what we have is the same numerator, x minus 2, which we can treat as a lump. Remember the divide sign, this main divide sign right here says that what we have is some factor divided by some other factor. If those aren't identical, we can't cancel them in fraction form. Remember, what we're doing with the fractions is simply reducing by pulling out common factors to the numerator and the denominator, which equal 1. So right now, in the original form, we don't have identical factors. However, if we factor x squared minus 4 and turn it into a completely factored form, we now have three factors: x minus 2 in the numerator, and on the denominator we have x plus 2, and the other factor x minus 2. Now, conveniently enough, x minus 2 is identical to x minus 2, which means when we cancel each of those, we can replace each factor with 1. And of course, what that means is our result is, and don't forget the 1 over x plus 2, which is a much simpler form. One other thing that you need to pay attention to here is that any problem that's written like this, where you have a rational expression, you have to consider the cases where the denominator cannot be 0. And so what that means is it's very nice when you factor it. You can tell immediately that this whole problem doesn't make any sense if x equals negative 2 or positive 2. And so it's usually good to have the disclaimer that x is not allowed to be negative 2 or 2. Otherwise, this problem doesn't really make any sense. Sometimes this is a focus of the problem, and other times it isn't worth worrying about. It's assumed, and most of the time what you're trying to do is simplify some rational expression to do something further in a problem. But this skill allows us to do this problem and simplify to that with the stated assumptions that x doesn't equal negative 2 or positive 2. Let's take a look at some more problems. Here we have another rational expression that looks even more complicated, but again, we step right in and try to factor it, because any fraction in factored form means that we can simplify that fraction by canceling like factors. So if we factor the numerator, it factors to 3x plus 1 and x plus 2. You can check that for yourself. And you can also pause it and try to factor the denominator yourself, but if you've come back to do so, you'll find that it factors to 3x plus 1 and x plus 4. So right now, again, we have a clear set of factors that are identical, 3x plus 1 and 3x plus 1, so that equals 1 over 1, and of course anything 1 over 1 is just 1, so we're left with our final result of x plus 2 over x plus 4. Once again, this problem doesn't make any sense as long as x equals negative 4 or x equals negative 1/3. So those would be the disclaimers, you could argue, where the problem doesn't make sense. So you restrict it to all values of x where x does not equal negative 4 or negative 1/3. And once again, we have simplified a fraction rational expression that looks much more complicated. Let's take a look at another one. So here's another rational expression, and this time it's a rational expression divided by another rational expression, which means we need to, and it's a fairly complicated one, we need to factor all of this as much as possible and also use our fraction dividing and multiplying skills. What that means is, of course, it's going to be the first rational expression multiplied by the reciprocal of the second rational expression. I'm going to factor each of these, and I'm also going to turn it into the reciprocal and the multiplication for the second one. So be careful, that's kind of all in one step. So the first rational expression we can factor by pulling out a greatest common factor and recognizing that what we have is a difference of two squares. So we'll come back to that and finish that off in just a moment. And the denominator is 2n minus 3 and n minus 1, I believe. Yeah, they both need to be negative. 3n, 5n, yes, okay. And then multiplied by the reciprocal of this one. So the 6n squared plus 7n minus 3, which I'm going to put on the bottom, factors to 2n plus 3. And 3n minus 1, and you can double check that for yourself. The inners are 9n and the outers are negative 2n, so that contributes to positive 7n. There we go, good. And the denominator, which I'm going to put on the numerator, is a pretty simple factor of n minus 8 and n minus 1. Now remember, when you're multiplying two fractions together, you multiply the numerators together and multiply the denominators together. So we can treat this as one big fraction. And I'm going to factor the numerator as the difference of two squares, 2n minus 3 and 2n plus 3, and n minus 8 and n minus 1. And on the denominator, we have 2n minus 3, n minus 1, 2n plus 3, and 3n minus 1. And of course, now we can go crazy with canceling. 2n minus 3's cancel. 2n plus 3's cancel. Remember, these are just factors that we can cancel. So as long as the factor is identical, with 1 on the denominator, we can cancel. What this results in is 2 times n minus 8 over 3n minus 1. You could also distribute that back out, give yourself 2n minus 16 over 3n minus 1. In any case, once again, you would put restrictions on this, and there's a lot of them, because there's a lot of stuff that shows up on both the numerator and the denominator throughout this problem. So n couldn't equal 8, couldn't equal 1, couldn't equal 1/3, couldn't equal negative 3/2, and it couldn't equal 3/2. So what textbooks often do is they kind of give lip service to this early on in the chapter and then say, okay, from now on we're assuming none of the factors are equal to 0, and that's a perfectly valid thing to do. But I'd just like to remind everybody that you are thinking about those restrictions. Let's take a look at another couple of problems. Now what we're looking at is a fraction minus a fraction, which means we need to get a common denominator. So to get a common denominator, you need it would be best to find the least common denominator. And once again, that means we need to know what the factors of the denominators are, and then get a common denominator. When doing that, we'll need to then get equivalent fractions. So we can write that this is equivalent to 3 over 2x plus 1, where we have factored out an x, let me extend that line, minus 2x over 3 times 2x plus 1. That means these two denominators share a common factor of 2x plus 1, which means that our LCD, let me do this slightly differently, our LCD is going to be the least common multiple of those two denominators, which means our LCD is actually going to be, in this case, 3x times 2x plus 1. And what we really need to do is figure out what we have to multiply each fraction by to get that common denominator. So clearly we're going to come along and say we need to multiply the denominator by 3 and the numerator by 3, which means that our new fraction is 9 over 3x times 2x plus 1. And we're going to look at the second one. What we realize is in order to get that denominator, we're going to multiply both the denominator by x, which means we need to multiply the numerator by x, which means that now with a common denominator of 3x and 2x plus 1, we're going to get 9 minus 2x squared as our numerator, and what this gives us is 9 minus 2x squared over 3x times 2x plus 1. Now, not going to worry about what x can and can't equal, but it is worth commenting that at this point you should try to factor the numerator to see if after doing all of this you wind up getting any common factors in the numerator and the denominator so that you can reduce further, just like in the previous problems. This particular problem does not have anything that reduces. We can't factor the numerator at all. There's no 3 common to each of them, and there's no x common to each of them. It's not the difference of 2 squares. So we would be done. And let's take a look at one more problem. This final problem actually is related to the previous one we just did, in that we're actually now solving an equation, which means that what we're going to be doing is clearing the denominators. Now, clearing the denominators means multiplying by all the factors that will eliminate a denominator. And so, once again, it's useful to factor each term here. So what we have is 4x over x minus 5 and x plus 6 plus 2 over x minus 5. Didn't write that very well. 2 over x minus 5 equals 1 over x plus 6. So what you can see here is all 3 denominators, the least common multiple would be x minus 5 times x plus 6, which means we could multiply both sides of this equation by x minus 5 times x plus 6. That'll clear the denominators here, so this will get eliminated. So what we're going to do is multiply everything by what I've just circled, which means that that term is just going to wind up being 4x. So what we're doing essentially is multiplying each side of the equation. I'm going to write it a little lazily. I'm going to write x minus 5 times x plus 6, excuse me, times the entire equation. But what I'm doing is multiplying each side by that. And what that means is the first term just winds up being 4x, because 4x times x over x minus 5 over x plus 6 multiplied by x minus 5 times x plus 6. The numerator, the thing we're multiplying by, cancels the x minus 5 and the x plus 6 completely. Now, in the second term, the x minus 5's cancel when we multiply, so let me kind of remind you that what we're doing is distributing to each term here by writing it like this. So remember, we've created this multiplier of x minus 5 and x plus 6 so that the x minus 5's cancel and the x plus 6's cancel. So what that means, our middle term here is going to be 2 times Once the x minus 5's cancel, we still have a factor of x plus 6 that we're multiplying by. And on the right-hand side of the equal sign, the x plus 6 terms factors cancel, leaving us with 1 times x minus 5, or just x minus 5. Okay, so now we have a fairly simple equation that we can solve. This is going to give us 4x plus 2x plus 12 equals x minus 5. Let's see, that's going to give us 6x, subtract x, so 6x plus 12 equals x minus 5. Subtract x from each side, that's going to give us 5x over here. Subtract 12 from each side, that's going to give us 5x equals negative 17. We're going to divide each side by 5. Let me bring that over here. So divide by 5, divide by 5. And what we're going to get as a result is that x is negative 17 fifths. So we've actually solved a fairly complicated looking equation and gotten a fairly straightforward answer for x. Sometimes when you solve these you'll get a quadratic. Sometimes you'll get something worse, but in this case it was clearly designed so that it would solve fairly nicely. So this harkens back to the skill of clearing denominators in an equation, but uses the tools of being able to use factored form for quadratics, and allows us to simplify and solve very complicated looking equations in nice fashion. Once again, the solution, what you should do is double check that solution doesn't cause you to have any of these terms or denominators equal to 0. And of course it doesn't. When x equals negative 17 fifths, none of those denominators are equal to 0, so it's a perfectly valid equation. You don't need to put a restriction on anything. I hope that's helped.